One of the first things you want to learn is the different physical attributes and how they work. Learning the differences now will save you time when working on your own simulations later. One thing that's nice about these attributes is they behave like they do in reality. This makes it a lot easier to choose what you want to use for your simulations. Here we have a scene set up with different attributes assigned to spheres. When the simulation is ran, you'll begin to see how they differ from each other. See how each one bounces differently? This is because of the differences in the attributes. These attributes go beyond just bouncing too. Friction, elasticity, coarseness, mass, and resistance to air are all accounted for when attributes are assigned to objects, just like in the real world. Watch how each object travels down the slope. See the differences? Let's break down each physical attribute. Rubber is good for objects that you want bouncing around for a while. It stores its kinetic energy a lot longer than its other counterparts. Glass is good for objects that are hard, really smooth, and travel fast. Iron is good for objects that need to be heavy. Because iron is denser than other attributes, its weight makes it ideal for smashing apart other objects. Styrofoam is good for objects that need to float down from the sky like leaves, or objects that need to be light without the need for a lot of elasticity. Like styrofoam, paper is good for objects that need to be light and not have much kinetic energy. Like its real-life counterpart, wood is great for objects that will be struck by other heavier objects. Its weight will keep it from flying out of the scene, plus its elastic properties will ensure it to bounce a few times before it stops. It also has a semi-smooth surface which lets it slide for a while. Rags is a good attribute for objects that need to be light, have a rough surface, and can be affected by wind and air. As always, experiment. Learning how these attributes behave will help you to learn the capabilities of TrueSpace's physical simulation system.